Hi there guys, and welcome to this video which is going to be focusing on how you can work out the molecular formula of a compound, otherwise known as the empirical formula, from the starting masses. So when we talk about the empirical formula, just to give you a quick definition, what you're looking for is the simplest ratio of atoms in a substance. So in an exam you might be given a question that looks like this. You might say a hydrocarbon contains 72 grams of carbon and 12 grams of hydrogen. Calculate the empirical formula. So the aim of this video is to give you the skills to be able to answer a question like this. Now there are three key steps. The first one is to work out the moles. The second step is to divide both by the smallest number. And then the third one is to use that ratio to work out the formula. Now that probably sounds like a bit of gobbledygook, so let's go through a worked example. So we know from the question that we've got 72 grams of carbon and 12 grams of hydrogen, and we need to work out the moles. So in order to do that we need to use the following equation. So the exam question will always give you the atomic masses. So we know that for hydrogen I start off with 12 grams and I have an atomic mass of 1, therefore it is 12 divided by 1. And carbon I have a mass of 72. And I have an atomic mass of 12, so it's 72 divided by 12. So this gives me 12 moles for hydrogen and 6 moles for carbon. Now the second step is to divide both of those numbers by the smallest one. So in this case it's 6. So what I need to do is divide 12 by 6 and then 6 by 6, which gives me a ratio of 2 to 1. Now the final third step is to take that ratio and to turn that into the formula. So I've got 2 hydrogens and 1 carbon, therefore I have CH2. So if you follow those 3 steps you should get the correct answer every time. The examiners do like to put in a bit of a trick question every now and again though, so let's have a look at that now. So the question says 14.3 grams of an oxide of copper contained 12.7 grams of copper. What is the empirical formula? Now the mistake people make here is they put 12.7 grams for one and 14.3 for the other. However, that's not the case. So if we have a look at the masses, I have 12.7 grams of copper. It doesn't actually tell me my oxygen. That 14.3 is the total mass of the oxide. So therefore 14.3 take away 12.7 gives me my mass of oxygen. And that comes out to 1.6 grams. So the rest of the steps are exactly the same then. So write down the atomic mass underneath. So copper is 63.5 and oxygen is 16. From here on out everything is the same. So to work out the moles it's mass divided by mR. So in this case it's 12.7 divided by 63.5 for copper and 1.6 divided by 16 for oxygen. And that gives me 0.2 moles for copper and 0.1 moles for oxygen. The next step is to divide both by the smallest number, which in this case is 0.1. So 0.2 divided by 0.1 and 0.1 divided by 0.1, which gives you a 2 to 1 ratio. So for step 3 then, I've got 2 coppers and 1 oxygen, so that gives me Cu2O, which is the correct answer. Right, let's have a look at a question then and see how much you've picked up from the video. So this one says 0.414 grams of lead reacts with 0.064 grams of oxygen to form a lead oxide. Calculate the formula of the lead oxide. The relative atomic masses are 207 for lead and 16 for oxygen. Pause the video, have a go, and we'll see how you've done in a minute. Okay, so the first thing you need to do then is put down the mass, which is 0.414 grams for lead and 0.064 grams for oxygen. Underneath that, put the atomic mass, which for lead is 207 and for oxygen is 16. Then you need to work out the moles, so divide both of them by their atomic masses, so 0.414 divided by 207 and 0.064 divided by 16, which gives me 0.002 for lead and 0.004 for oxygen. Once you have that, you divide both by the smallest number, which in this case is 0.002. So 0.002 divided by 0.002 is 1, and 0.004 divided by 0.002 is 2. So from that I can work out my ratio. I have 1 Pb, 1 lead, and I have 2 oxygens. Therefore my formula is PbO2. Now this was worth 3 marks, so your first mark was for dividing the mass by the MR, second mark was divided by the small number, and the third mark is for the correct answer. Okay, that sums up this video then. So we'll move on to the review, which is 48 grams of magnesium combines with 320 grams of bromine. What is the formula of magnesium bromide? It's also worth 3 marks, and you've also got the relative atomic masses. That should be straightforward for you now, which ends this video. Hi guys, hopefully you've enjoyed the video. If you have, click the subscribe button down below and visit the website mrbarnestc.com for more.